Pinellas Beautiful to talk to Devin Frank about microplastics. Come on in. So we're going to meet Devin today. He is an expert on microplastics.
Hi Laura, how's it going?
Hey, good. How are you?
Doing great. Great to see you.
You as well.
Yeah, today we're going to be talking about microplastics. Let's go.
All right.
Before we can start talking about microplastics, which are very tiny pieces of plastic, we need to understand the bigger picture of where they come from and what they are. The problem of microplastics in our environment is directly related to one of the world's biggest environmental issues. Can you guess what that might be? That's right, trash, which leads to littering and pollution. Littering is waste out of place, or when people don't properly dispose of their trash. Littering leads to pollution, which is when a lot of man-made waste gets into and can harm the environment. And the majority of this litter, or pollution, is made out of plastic. So what happens to all that plastic that gets littered? Do you think it just goes away? Well, the answer is no. What do you think does happen to all that plastic litter? Where do you think it ends up? Well, it gets washed away by wind and rain and ends up in streams and rivers, all of which eventually lead to the ocean. Once that litter enters the ocean, it becomes what's called marine debris. But what is marine debris? Let's find out.
Marine debris is all the man-made stuff that ends up in the ocean, from soda cans, plastic bottles, and that sun hat you lost last summer, to abandoned fishing gear, entire vessels that are sunken or marooned, whether it got there on purpose or by accident. And even if that hat happens to fit a certain octopus just perfectly, it still qualifies as marine debris.
Can you think of any examples of marine debris? It could be pretty much anything. Metal, like aluminum cans or shopping carts, sunken boat, lost fishing gear, glass, wood, and yes, plastic, like plastic bags, plastic bottles, and more. Of all the different kinds of marine debris, plastic is the most prominent. It makes up about 95% of all marine debris. This is quite impressive. Plastic has only been around for the last 60 to 70 years. So how do you think all that plastic gets in the ocean in the first place? Do you think people just drop it all off of boats? Well, some of it falls off of boats, but actually 80% of all the litter pollution that ends up in the ocean starts in communities that are inland, away from the ocean. That's pretty crazy. And there are problems at every single step of the plastic making and plastic using process that can cause it to end up in the ocean. For instance, plastic litter can be created during the manufacturing process or when it's being made, during the packaging process, while it's being distributed, and then when it gets into our hands based on how we use and dispose of it. For all that plastic litter that starts out on land, it will end up in the ocean if it's not collected by street sweepers, stormwater catchments that collect litter before emptying into a river or the ocean, or if it's not removed by people at a beach or other environmental cleanup. Long story short, the problem of plastic litter and marine debris is a really complex and difficult one. So now we know that plastic is getting into our ocean. But does it really matter? I mean, is there enough out there that it could actually be a problem? Well, what if I was to tell you that in 2010, just 10 years ago, there was an estimated 606 billion pounds of plastic waste in the ocean? If you were to count 1 pound of that plastic per second without stopping, it would take you 19,216 years to count it all. Wow is right. About a third of all that plastic was within about 20 miles of coastlines around the world. Just that third of the plastic that was close to the coastline was the same weight as 302 Empire State Buildings. Stacked end to end, that many Empire State Buildings would stretch from downtown Tampa to downtown Orlando, Florida. Alright, so now let's jump forward 5 years to 2015. There's now an estimated 732 billion pounds of plastic waste in the ocean. That's the same weight of 1 million Boeing 747s, one of the biggest airplanes in the world. In that same year of 2015, Americans are now using about 306 pounds of plastic per person per year on average, which is the same weight as some of the heaviest players in the NFL. And Americans are using about 50 million single-use plastic soda or water bottles every day. Stacking those 50 million single-use plastic bottles end to end would stretch from Beijing, China, all the way to Los Angeles, California. And that's just one day. So let's jump forward to today. More and more plastic continues to be generated or made every year. So how much plastic is in the ocean exactly? Truth is, we don't exactly know. Lots of scientific studies have given us some good estimates, and we know that it's found in every ocean. But we can't find more than 95% of the plastic in the ocean that we know is there. Why do you think this is? Where do you think all of that plastic might be? Well, it's not all floating at the surface. Some is below the surface or even at the bottom of the ocean. Some is in the sediments or the sandy material at the bottom of the ocean, and in the sand along the shoreline. And some animals eat it. And some of it is so small that we can't even see it. But more on that later. Although we can't see it all, what we do know is that about 18 billion pounds of plastic enters our ocean every year, becoming plastic marine debris. To put this into perspective, this would be the weight of about 1.5 trillion plastic grocery bags. If you were to stack 1.5 trillion plastic grocery bags end to end, it would stretch from the Earth to the Sun 65 times. If these trends continue into the future, by the year 2050, the weight of all the plastic in the ocean will be more than the weight of all the fish. You might be asking, so what? Why does it even matter if there's that much plastic in the ocean? Well, this much plastic in the ocean is a big problem. As plastic is lightweight, it travels quickly with wind and currents in the ocean, so it can be found everywhere. And like we said, while much of it floats, some of it is found in the middle of the water column below the surface, and some is found at the bottom of the ocean. This makes sampling very difficult. All of this plastic pollution can lead to destruction of habitats in the ocean, which are places that ocean animals live in and depend on to survive. Plastic marine debris can transport or move invasive species into a habitat where they don't belong, where they can outcompete the animals that normally live there for food and shelter. This plastic waste can pile together, meaning that it needs to be removed, which can cost a lot of money. And it can create navigation or safety problems for boats and ships. Plastic debris can hurt places that depend on tourism. Studies have shown that more debris on the beach has led to less people wanting to visit those places on vacation. And all that plastic in the ocean really ends up hurting animals that live in or depend on the ocean. As of 2016, more than 690 species have been documented either getting tangled in or eating plastic in the ocean. Amazingly, this includes 80 different species of seabirds and 90% of all birds within those 80 species. This is bad, as plastic is made of toxic chemicals, which can then end up getting absorbed into the animals' bodies. The plastic often causes these animals to stop eating because it makes them feel sick, or get stuck in their stomachs, making them feel full. Animals will waste energy trying to digest it rather than using that energy to swim, fly, or do other normal behaviors. Due to this decrease in energy, animals can't migrate like they normally do, making their long voyages across the ocean, and also can't have as many babies or even healthy babies like they would without having eaten plastic. And as you might expect, ingesting plastic leads to a higher death rate for ocean animals, which leads to smaller populations.
All right, so now we know what happens when plastic gets in the ocean and why it's so bad.
Right.
So, what do you think happens next?
I don't know, Devin. What happens next?
Well, we've actually gotten an example of some actual marine debris right here. So these are straws, just some of the straws that we've picked up over the last year or so with some of our beach cleanups. Straws are a very common thing that you'll see washed up here. And as you can tell, they don't just stay the way they are out in the ocean. They actually kind of start to break down and break apart a little bit. Like you can see, like for instance, like this straw here. It's breaking apart into smaller and smaller pieces. So we're going to do a little demonstration here to try to figure out what happens to this plastic over time when it's in the ocean.
Okay.
What happens?
Great.
Does it stay the same size? Does it get smaller? I don't know. Let's find out. So we're going to take 4 straws that we collected from this bucket. We're going to pretend that this is marine debris. and it actually was marine debris. And we're going to put it in our little miniature ocean right here, which is our blender. We're going to represent what happens over time in the ocean. When you add plastic to the ocean, but then also add in some sunlight, some wind, some waves, this is what's going to happen.
Whoa! Some of these pieces are smaller than the size of a grain of rice now.
Some of them are. My question is, we started with 4 full straws in there. How many full straws, in terms of plastic amount, do we still have in this blender?
Even though they're in smaller pieces, the same amount of straws are still in that blender.
You're right. The same amount of plastic that we started with. We still have the 4 full straws worth of plastic in here. And what we're noticing now, it's looking like kind of like pretty confetti.
Yeah.
And as these pieces get smaller, it's now not just the big animals that are interacting with that plastic and being harmed by it, but now the smaller animals and the baby animals can start to eat it and things like that too.
Well, does it get even smaller than that?
It can, actually.
So what are microplastics exactly? Well, microplastics are defined as pieces of plastic that are smaller than 5 millimeters or 0.2 inches in size. That's pretty small. Microplastics can be made in factories like Nurdles, which are in the picture in the top left of your screen, and those are little plastic pellets made to be melted down and turned into larger pieces of plastic, like bottles and bags. And there's also microbeads in the lower left corner of the screen, which you might find in personal care products like lotions and toothpaste. And microplastics can be made by the natural weathering process of the ocean, breaking down big pieces of plastic into little tiny pieces, like the 2 images on the right on the screen. As we mentioned with the blender demonstration, when you mix plastic with ultraviolet rays from the sun, wind, and wave action stirring it all together, it will break apart into microplastic. Science of microplastics is still very new, so there's a lot we don't know. But we do know that the longer the plastic is in the ocean, the more it will break into smaller and smaller pieces, meaning that the risks of microplastics to animals and the environment increase as time goes on. So where can we find microplastics in the environment? Well, the answer is everywhere. They come from lots of different human-based sources, even some very unlikely ones.
Every day, the world throws away billions and billions of plastic bottles. That's a problem. Of course, the real solution is that we all use less plastic. But it's cool that even while we work to reduce plastic, some companies are turning trash into stuff we actually like. Drink it, drop it in the bin, take it to a recycling factory, chop it up, weave it, wear it, wash it, wear it again, wash it again. Seems like a great solution, right? But darn, when we look closer, there are some real problems with this. The big problem is that some people might be encouraged to use more disposable plastic if they think it's being recycled safely. But there's also a little problem, a micro problem that's adding up to one big mess. Every time we wash synthetic fabrics, whether they're made from recycled bottles or brand new materials, super tiny pieces of plastic, called microfibers, wash off and flow down the drain. Up to hundreds of thousands each wash. The older our clothes get, the worse the problem can become. Yikes! These fibers are so tiny, water treatment plants don't catch them all, so they wind up in rivers, lakes, and even the ocean.
So as we've seen now, microplastics can be found everywhere, including at the sea surface, on our beaches, within the ice in the Arctic Ocean, in the deep sea, even in freshwater, rivers, and wastewater. Some pieces are so small and light, it's even floating in the air. We find microplastics in things we drink, even in our tap water and bottled water. How does it get into these systems? Well, the science of microplastics is still so new that we don't know for sure. But it is currently estimated that there are somewhere around 33 trillion microplastic particles just at the ocean's surface. Let's compare this number. This is 130 times more than the number of stars in the Milky Way galaxy. If you were to count each individual microplastic at a rate of 1 piece per second without stopping, it would take you over 1 million years to count it all. You might have been thinking that these tiny pieces of plastic are bad for the environment and wildlife, just like the big pieces are. Well, if you were thinking that, you'd be right. Floating microplastic transport invasive species like germs, bacteria, and viruses that live on the surface of the small pieces of plastic as the plastic moves around the world. When animals ingest these microplastics, they can get very sick. So why do animals eat these microplastics? What happens to them when they eat it? Well, let's find out.
The birds, fish, filter feeders, whales, and crustaceans around it are just going about their daily business, which means they're looking for food. Unfortunately for them, tiny bits of floating plastic look a lot like fish eggs and other enticing bits of food. But once ingested, microplastics have a very different and terrible habit of sticking around. Inside an animal's stomach, they not only damage its health with the cocktail of toxins they carry, but can also lead to starvation. Because although nurdles may be ingested, they're never digested, tricking an animal into feeling like it's continually full and leading to its eventual death. When one organism consumes another, microplastics and their toxins are then passed up through the food chain.
As of 2017, there have been at least 220 different species that have been documented ingesting or eating microplastics. While only the big animals could ingest the big pieces of plastic in the ocean, now the really small animals are sadly eating the plastic too. The plastic can make the animals sick, often causing tumors. It slows the growth of animals that eat it, making them at a disadvantage for finding food and shelter. It can change an animal's behavior, altering nesting behavior, swimming behavior, and an animal's ability to survive. It hurts reproduction too. Animals have fewer offspring, fewer babies, and those that do survive are less healthy from the start. And as you might expect, the plastic is toxic. Not only do the chemicals that make up the plastic get into the animal's system, but the plastic also absorbs chemicals in the water that are also then eaten by the animals. But why does this matter to us? Well, people eat ocean animals. And as we've learned, all those toxins eaten by fish might be transferred to us too. I don't know about you, but a meal of plastic doesn't sound very good to me. Very little is known about how microplastics affect people, so it's really important that we study them so we can learn where they are and how much is out there.
So yeah, the question is, where is it? How do we know how much is out there? So there are different methods that different scientists are using around the world to study this.
I want to get involved. How could I find some microplastics?
We actually have citizen scientists that are interested in this and are going out, and they go out and they can literally just scoop up a sample of water and bring it back to a lab and analyze what's in just that 1 liter water sample that they've collected.
Maybe I could try.
Let's show you how that works.
Awesome.
Great. Follow me right this way. Ready? That's it. The sample is collected.
Okay, so I made it to Cross Bayou. I'm under the bridge. I found the water. I'm going to collect my water sample. Got it. We're going to take this 1 liter sample of water back to the office to analyze it under a microscope and see if there's any plastic in the water. All right, I got my water sample.
Awesome work. So we got to get all the water out, and we're going to do that by using a vacuum filter. We've got this set up that we're going to pour the water in the top, and it goes through this little tiny piece of paper. It's actually 0.45 micron filter paper. So what that means, that's a very, very small number. 1 micron is 1/1,000,000th of a meter. The little holes that are going through the paper. So anything that is bigger than 0.45 microns is going to get stuck on this piece of paper.
Okay, cool.
And then when we're all done, we can take this piece of paper, look at it under a microscope, and see what's on there, and maybe we'll see some microplastics.
All right, let's do it.
So I'm going to pour the sample in. You see it's already running through, catching anything in the water that's bigger than 0.45 microns in size. But once this is empty, we'll have all of the contents from in here on that piece of paper. There are some studies that have come out recently too that estimate that the average American is eating about a credit card's worth of weight in plastic a week.
A week?
A week. So that's not going to be everybody. That's the average. Well, now that we're done filtering it, the next step is here. Now we've got our piece of paper with all of that gunk on it. But now we got to figure out, do we have any microplastics in there? So we're going to use the microscope to take a look and see what we can find.
Okay.
This is all gunk that was collected from the ocean, but it's a variety of organic material, possibly plastic material, we don't know yet. That was in that 1 liter sample, now all on a piece of paper. I'm going to put it under the microscope, and let's see what we can find. Scanning the filter paper here, looking to see what we can find. All this looks like natural organic material, algae or other types of sediments possibly, but oh, wait, we found a little blue fiber here. This might be worth taking a closer look and seeing what this is. This could be natural, it might not. This could be a piece of plastic.
How do we know?
Well, we're going to do something that's called the flame test. So we actually need to pick up this tiny, tiny fiber that we can't even see with our eyes. We have to use the microscope to see it. We have to use a very fine point forceps. Pick it up and put it over an open flame for about 1 second. See how it reacts. If it bubbles and melts, we know it's plastic. If it singes and turns black on the edges, we know it's a natural organic type fiber.
It melted! It's plastic!
You're right, it did melt. That is plastic. So we have found a plastic fiber on our sample here. As you can tell, look at the edges there. You can see how the edges have kind of melted. So that's how we know. So we'll write this one down as a piece of plastic. The first one we found in our sample here. Flame test showed that this one melted too, so yep, that one's plastic.
It looks like we found some plastic in our water. So
We did.
now that we have that information, what do we do with it? Why are we even doing this?
Well, the answer is education and awareness. We're trying to make sure that people understand and know that there is not just big pieces of plastic out there, but those big pieces of plastic turn into small, even more dangerous pieces of plastic that can be harmful not just to the animals that are on the ocean, not just the big animals, but now the very small animals, and even potentially to us. So this is all about awareness. It's also about getting people involved. This is a citizen science project that we have here with our organization here in Pinellas County, Florida. And we would love to get more citizen scientists involved in collecting these water samples. We're actually partnering with the Florida Microplastics Awareness Project, which is part of the University of Florida. And they actually are studying different areas around the entire state of Florida. So we're contributing the data that we collect right here in Pinellas County back to them. So part of their statewide database that they can use for their scientific studies. We're doing this so that everyone can understand the amounts of plastic that are out there and what we can do to stop it.
Because I didn't even know it was out there. We
It
can't
is.
even see it, but it's in our water. It's everywhere.
It is everywhere out there.
What exactly can we do to help prevent this from happening?
Prevention is much easier than trying to go out and clean up all of these little tiny pieces of plastic that we can't even see.
Hope is not lost. The best solution to stopping plastics and microplastics from hurting us ocean animals, and the environment is for us to prevent plastics from getting into the ocean in the first place.
So the best way we can do that is by trying to limit the amounts of single-use plastics that we are using. Like all of these straws that we've collected from the last year, just in some of our cleanups. These are the types of things that we don't necessarily need to use.
Well, that sounds easy. Let me do it.
All right.
Sign a pledge.
You can do this by taking the plastic-free pledge to help prevent single-use plastics, which are plastics we tend to use one time and then throw away, stopping those from getting into the environment. The link to the pledge is attached to this video.
Well, do you want to help too? It's easy. You can take the pledge to reduce the use of your single-use plastics. Bring reusable bags when shopping and avoid using plastic bags. Carry a reusable water bottle and coffee mug. Avoid plastic straws. Reuse food containers, lunch bags, and utensils. Skip products containing microbeads like personal care products. Buy clothing made from natural fibers. Stop releasing balloons intentionally. Dispose of cigarette butts properly. Pick up litter. And responsibly dispose of all my trash. It's easy. I'll take the pledge.
You have the power to make a difference. It's not about making huge changes to how you live your life. It's about making small changes over time to limit your use of single-use plastics. Take the pledge. Teach others what you now know about the dangers of plastic and microplastics. Join local beach, neighborhood, or park cleanups. Let's make this a better, cleaner, healthier world for us and all the future generations.